Hey everyone, welcome back to another video. So this episode began with trying to do a little bit of work on the tune on the SC. And in doing so, I figured out that the alternator is not charging. And also, one of my little caps, it was actually this cap on the passenger side, came off and put a bunch of oil all over the engine bay, unfortunately. Brand new parts and everything else. The last thing I wanted to do was cover them in oil, and unfortunately that's what happened. So I cleaned everything off, no harm, no foul, but it instilled the necessity in my mind to build a new catch can for this thing. So I had a catch can before, right here, but with the new position of the wastegate provisioning, or the wastegate recirculation tube, I should say, didn't leave enough space to have that catch can still be in here. And similarly to the header and everything else, I can do a nicer job now than I could when I built the initial catch can. So what this episode will be is kind of a step-by-step DIY on how to make a cheap catch can for your projects as well. With all of my projects, money is running a little bit thin right at this point in time. So I'm going to do this as cheaply as I possibly can, digging into my stash of old parts and components and everything, as well as my stash of aluminum sheet. So materials-wise, what we have to start at least, we have a number 8 ORB bung. That will be the drain along with this cap. We have a K&N filter. This was an extra one that I had ordered when I built the Mark II's catch can. We have some hose ends if I can't make use of the old hoses. And we have two number 10 adapter fittings that I'm going to cut the number 10 portions off of. And these will be our inlets to the catch can. So when you are building a catch can, the first and most important thing to do is to figure out the dimensions in the space that you are working with. If you don't do that, then you'll just end up with a box, or you have the possibility of ending with a box that doesn't really fit in the space that you are working with. So for this, I'm going to build the catch can kind of in this void right here. That's where the other one sat, and it's a pretty easy and pretty effective place to position a catch can. So what I need to do first is to figure out what the dimensions are going to be for it, draft up the most complicated panels, cut those out, and then we can move on to the easier panels from there. So as I'm doing this, I generally like to use a piece of paper, and in this case I'll use a pencil, so that way if I make any misdrawings or any missteps in the process of this, it's easily rectified without destroying my entire draft. So what we need to do is figure out kind of our maximum space that I have to work with here and the contours and everything else that we're going to work with. Unfortunately, this incorporates, or I have to work around some of the back of the wheel well, which makes this a little bit more difficult due to the fact that it isn't just a flat section or anything along those lines. There are some contours that I need to work around, but that is not the end of the world. So I have a stud here I can use to mount it, and a threaded hole on the chassis here, as well as a threaded hole here. So that'll give me my 3 points of contact, and that will prevent this catch can from rocking around or doing anything weird. So these are all things you need to kind of pre-plan as you're doing this, rather than just kind of flail at the end of it and hope that you can figure out a way to mount everything. It pays dividends to actually plan for that in the design process. So with that being said, it looks like I can make it about 8 inches long. I can make it, I'll probably do 7 inches wide, and then if I make it 7.5 tall, and I think that should work. actually we'll bump that down to 6 inches wide to give a little bit more room for a tab. 6 inches wide. And that gives me dimensions for just a box. But like I said, this will not end up being just a box. And now comes the more complicated drafting portion. So now that I have kind of my base dimensions sorted out, I can refine them and get it squared away with a more exact shape. So again, with my piece of paper here and my notes, I can make a little bit more refined drawing based off of kind of my limited or my dimensional limits of how this is going to work. So down in this corner, if I make it 3 inches and 6 inches out from there, I'll be into this area. There I do 4.5 height wise. Oh. We'll do 6 inches on the inside. And I think that should get us kind of the rough base of how this is going to be shaped and how we're going to build it. The rest of it I can refine as I'm actually cutting panels and fitting this thing multiple times. So let's take the dimensions that we have currently and start drawing an actual pattern for it, drawing an actual draft, and then we can transfer that draft over to aluminum and start cutting panels. Now we can begin cutting. And I went ahead and drafted out the back panel as well, as that's kind of an easy square panel to make. And now we can cut 1, 2, 3, 4, and 5 of our initial panels out. So in doing this, there are multiple ways to cut these panels. You can use an angle grinder, a vertical bandsaw, probably a cold saw or like a carbide tip saw. This depends on what the throw you have on the saw is. I'm going to use my horizontal bandsaw. And this is a little bit more of an automated cutting process. It'll make things a little bit easier to make these 5 cuts rather than having to exert a bunch of manual physical effort in doing so. So all that I need to do at this point is raise the beam of the saw up, match it up to 1, 2, 3, 4, 5 lines, make my initial easy cuts, and then the more precise tailor fit cuts I can do on the vertical bandsaw in a few moments. Now with all of the, at least initial panels cut out, or parted from the main sheet I should say, this is what we are left with. And now, which one of these do I cut first? Well, in theory I could cut any of them, but I'm going to start with this bottom panel, as these dimensions on this side here and this side over here, those are what kind of the rest of the can hedges off of. And if I cut this out first, test fit it, and it doesn't fit, then I can make alterations to it and therefore make alterations to the other 4 to accommodate how this fits. So the same way that we initially parted these panels, you can do these shape cutouts in a variety of different manners with a variety of different tools. I prefer to use the vertical bandsaw as I have a lot of control over the angles and everything that I'm attacking these cuts at, but it prevents a whole lot of cleanup work and everything afterwards. So as with any cutting apparatus when you are hands-on, PPE is very important. I wear these nitrile gloves so I don't get fingerprints all over everything. I wear an old pair of welding gloves to avoid cutting my fingers up and having them get cut by kind of rough edges. And then, if you guys can see me here, I also wear safety glasses and headphones to protect my eyes and ears. There we go, nice and simple first cut. Fairly straight, or as straight as I was able to get it with my hands and everything. Now, let's go ahead and take this piece, see if it fits in the car. So with our bottom panel cut, let me see if I can get this sufficiently on video. It is tight, but it does fit. And kind of the height that I place the catch can at will determine exactly how well this does fit. So I'd rather have it be tight than loose, and I think we should be good to go with this piece. So at this point, I can go ahead, cut the other 5 panels, or the other 4 panels out rather, and then we can start fitting and tacking together and figuring out where bungs and things along those lines are going to be located. Before I start tacking everything together, there is one more pretty important step that needs to be knocked out, and that is deburring and edge cleanup. So I got all of these cuts made as well as I could between the horizontal bandsaw and the vertical bandsaw, but you can see, hopefully, that there are some good burrs, like that one right where my hand is. There's burrs all along, and you really want to clean those up. I'm an advocate for being as efficient as you possibly can be, and on something like a stainless steel merge collector, I do the absolute minimum deburring that I possibly can. And that usually constitutes not deburring a whole lot on the inside of the collector, as I'm going to be welding it anyways. But for something like a catch can like this, since I'm not going to be welding the inside of it, I like to go ahead and knock off all rough edges and everything else so the weld, arc and the puddle and everything tracks as predictably as possible, and it just makes it a nicer end product. So let me get geared up again. Again, PPE is very important for this, and I can get all of the burrs taken off, and especially the sides that I cut on the vertical bandsaw, I can hold those up on my big belt sander, true those up, and everything will be good. And like I said, or like I have been saying, there are many tools and many ways to accomplish this. I'm using what I have here, but if you guys have an angle grinder, if you have a little Rolock disc, pneumatic die grinder, any tools can accomplish this. This is just what I have, what I prefer to use, and since I have the tools here, I'm going to take full advantage of them. So we have all of at least these 5 pieces deburred and ready to start becoming a catch can. So now it's time to tack everything together. And I'll usually do just some fusion tacks on the corners of all of these pieces. So if I do it on the corners, those will be my natural break points when I'm actually welding this together. And with each one of these seams, I like to have them be all one continuous weld. I don't like having stop starts and tie-ins on the middle of any of these joints. I think it's hard to get them tied in exactly perfectly so it looks aesthetically correct. So with that in mind, let me go ahead and get the welder fired up, switched over to AC, and we can start tacking all of this together. One thing I'll also do is I have this SPW 16 gas nozzle, gas lens. I don't need that for aluminum work, and rather than leave it on the torch and risk potentially having it arc out and destroy the diffuser, I switch over to this setup right here. This is just a number 8 gas nozzle that mounts up to what is called a medium gas lens. I find this to be my preferred setup to do any aluminum welding. it keeps the electrode nice and shielded, as tungsten itself is a reactive metal. And it keeps enough gas flow to keep the electrode from getting all mangled up while not overusing gas and burning up more of a bottle of argon than you absolutely need. Now we need to figure out the section that we're going to take out of the top panel to fit our breather filter. So I opted to go with a panel filter as opposed to a couple of little conical or cylindrical breather filters. I like these as you have a much larger venting area, and it makes it a lower profile piece. So what we need to do is to get this centered on our panel right here. So what I'm going to do is measure the length and width of this. And our length appears to be 4.492 inches. And our width is essentially 3.895 inches. So with that, I can go ahead and measure the actual panel, which its width is 5.997. And I won't be able to measure length with that, so we'll use the tape measure. And it is 6 7/16. So with those dimensions, I can do some simple subtraction to figure out what my spacing is going to be from each side inward to draw a box that I'll cut out on the inside of it. So let's do length first. So 6.4375 minus 4.492, 1.9455. Actually, I need to divide that by 2. If you don't divide that subtraction problem by 2, then you will end up with this would sit the whole way up to the edge of the panel, or I'd cut the hole way too small and that wouldn't be any good. So now I can go ahead and make a couple of marks on these two sides and draw a couple of lines. There we go. That should work out all right. Yeah, that'll be a press fit. Okay, now the width side of this. We'll do the same thing. 5.997 minus 3.895 divided by 2 is 1051. And there we go. That should be a rectangle that I can cut out of this panel and have the filter drop down in its home nice and happy. Now I need to figure out where I'm going to drill my relief holes so that way I can fit my little pneumatic body saw, or what I affectionately refer to as the buzz saw, into here. And I'm going to use this 3/8 drill bit to do so. So what I'll do is take the drill bit, put it on each of these corners, roughly aligning it to my marks. And then I'll just trace around the outside of it like so, then come in and kind of eyeball where the center of each of these circles is. This isn't a perfect science, but this also doesn't need to be absolutely perfect to work out. And there we go. We have our 4 center punch marks, at least roughed in. I can go over and I'll lightly tap each of these little crosshairs in these circles. I'll ensure that, at least by eye, I'm centered in each of the holes. If all of that is well, then I'll put a more aggressive center punch on them, so that way the drill bit doesn't walk around at all as I'm drilling these 4 holes. Once they're drilled, then I can come in with the body saw, cut that rectangle out, and verify that my filter does in fact fit. I cut my hole a little bit small to fit this filter in appropriately. So I'm going to come in with a carbide and very gently take a little bit off of all 4 of these sides until I get the filter to have the press fit that I want. Now, this is just an example of fabrication not being a perfect science, and sometimes you just have to break out the grinder and make additional clearance. And just like that, with a little bit of grinder work and a little bit of deep burring, this filter now has a really nice press fit into this top panel, and it is not going anywhere unless I want it to. So I'm good to go ahead and tack this upper panel back onto the catch can assembly. Or actually, no, we will leave it off for right now, so that way we can start working on the interior baffling. So the next thing we need to do before we start thinking about baffling the inside of this can is to figure out where our inlet fittings are going to be located. Without those locations pretty well squared away, we can't easily build the baffle setup, and we won't be able to deburr the inside of it once we punch the holes for our 2 fittings. So what I'm doing right now is taking the fittings with our 2 what I presume will be the hose ends that will actually be ran into here, and I'm positioning them on our can. So the reason I like to do it with the actual hose ends is the fittings themselves are generally of a smaller constitution or a smaller size than the fittings that you'll be welding onto the can. And it's really easy to put the fittings in a position such that it will be pretty much impossible to tighten them down or to run lines to them. When you put the hose ends on, you get a better visual representation of how everything is going to fit together, and therefore where exactly things need to be located at. So I've already gone ahead and marked out 1 location right here. And what I'm going to do is to take my straight edge and draw a line along the can, so that way they will be in the same position in terms of their height on the can. And now I just have to figure out what the spacing apart from each other will be. So this one sits something roughly like that. Then this one, I think I can put about here. And that will leave me enough clearance to be able to actually run the lines and all of that. So that's about the center point of our circle right there. Can come in, align that, make a second mark, and now I'm ready to drill the holes. and cut these fittings down and tack them onto the can. I cut a couple of other panels for the catch can, this bottom one, and then this front one right here. And now we are at the point where we need to start figuring out the baffling. So you'll see many times when catch cans are listed for sale, some elaborate style of baffling is listed, and while that's all well and good, baffling can be quite simple. And I generally try to make it as simple as it can be, because the main idea behind it is directing the incoming blow-by from your fittings down towards the bottom of the can and away from the filter. So when I make my baffling, generally I try to make at least a 2, if not 3-part baffle system. I'll put one panel that immediately blows any blow-by down towards the bottom of the can. And as I do that, I'm trying to have both minimal gaps to the sides of the inside of the tank, while still allowing, you don't want it to be a sealed system. You want some bit of a pass-through area for gases to make their way out. So I'll do one initial baffle blowing everything down towards the bottom of the can. Then I'll come in and do a second baffle that overlaps the first one. Both of these are pointing downwards. So any slosh or anything gets caught, if not by the first baffle, then the second baffle. And finally, what I've started doing with these panel style catch cans is I'll either use pre-existing perforated sheet, or I'll make my own perforated sheet and put that over top of where the two primary baffles overlap each other, and that I will weld the whole way around. So between those 3 parts, generally I found that I can minimize the amount of waste oil that actually makes its way up out of the can, if any does at all. Because you don't want a ton of nasty oil and everything all over your engine bay. We all take pride in our cars and want to keep them as nice as possible, and having them covered in oil doesn't really lend itself to doing so. So for this, since I have some complex shapes on the inside of it, namely this panel and how it interfaces with the other ones, I'm going to use some cardboard to make a template, and then from that template I can cut it out of aluminum, get it welded in here, and move on to the other 2 portions of the baffle. I have my 2 primary baffles now installed. You can see 1, 2, and like I said, number 2 overlaps number 1, so that way we're much less likely to have any blow-by make its way up to the top. So next, I need to make the perforated piece, and I don't have any perforated sheet here, but I do have this piece of 2-inch strip stock that I can make into a piece of perforated sheet. So this will sit right over top of that gap there. I'll get it all nice and fit in there after I drill all the holes, obviously. So that'll be the difficult part to begin, as whenever you are cutting or whenever you're making perforated sheet, you have to figure out the pattern and then punch a bunch of holes into this. So I'll get started on that. I don't think you guys want to sit and watch me drill a bunch of holes. But once I get this done, bring it back over, we can buzz it in, and then it'll be time, just about time, to cap this thing. The perforated section is now welded into the catch can, and I'm at the point now where I have to decide what, if any, little features and things along those lines that I want to incorporate into this can. And I have one that I am going to put into it that will require a little bit of additional fabrication, but not the end of the world. So right here is a dipstick tube that I made a little while ago. And this is going to go probably in this back corner right here where the top plate ties in. And it will sit, I don't know, the top of it may sit about 1/8 of an inch above the surface of this top plate. And it also has M6x1 threads. So whether I am able to get a dipstick, whether I make something, or whether I just use a long bolt, this will give me the ability to pull the dipstick out and have an idea of what level the tank's contents are actually at. If I didn't do that, then I would just have to wait for it to overflow or figure out some sort of a schedule to empty it out. And that seems like kind of a pain. I'd rather have a way to be able to tell exactly how much is in this can. Now, if you remember on the Mark II, I actually did a whole sight glass assembly on the side of it. But in sticking with the theme of spending as little money on this as I possibly can, I had this threaded boss, I had this section of aluminum tubing, so I just made this. It'll work perfectly, and all I have to do is punch a hole in this side of the baffle plate, sink this down to the appropriate depth, and then I can go ahead and weld that in, and then it will be time to weld the top panel on and to make this final back panel. And then I guess it will be time to weld the entire can up. There we go. The can is well welded aside from the drain bung, which I have right here. That's what we'll take care of next. But everything came out pretty nicely with this. It's always interesting to see the colors when you're welding anodized fittings, the colors that they change as you heat everything up to weld it. So most of the welds came out all right. Some of them were a little bit funky, but it is what it is. I can certainly live with what we have here. So, drain bung. It is a number 8 ORB bung. That way it's nice and O-ring sealed. It isn't an MPT thread where it's tapered and you can possibly have the threads gall and seize and all of that. Ends up not being a good deal. So I went and looked in the engine bay, and it appears as though this corner right here is going to be the ticket for this bung. So what I usually do with these is I'll line them up kind of to the edges of the outside corner welds, kind of what you see right there. I like that, so it sits right up on a corner, and that way you can kind of tip the can to that corner and be able to drain it a little bit easier than if you had it just in the middle of the bottom of the tank or anything like that. So I'll mark this out, go over, punch the hole for this in the bottom of it, which will likely be a combination of a hole saw and a carbide if it needs to be kind of tailor fit. Then at that point we can pop that in, weld it up, and the can will be all done aside from mounting it. There we go. The drain bung is now in place. Welds came out pretty nicely. I really enjoy welding kind of circular aluminum bungs. I don't know what it is. They usually come out pretty nicely, and I have a lot of fun doing them. But we have one last order of business to take care of today before we come in tomorrow and figure out the mounting for the can. And that is to clean this mess. So you can see there's aluminum chip all over the floor. This place is just a disaster at this point. And that's just kind of the way that it goes, especially when you're working with aluminum. It puts a ton of chip down. And one of the things I like to do at the end of each day is clean the fab room to the best of my abilities. I don't do a super deep clean, but clean it up a little bit, at least so you're not walking into a disaster the next day. I find for me, if I'm coming into a nice clean or clean-ish area, I'm much more likely to want to be there as opposed to the disaster that this is right now. So I guess without further ado, let's do some YouTube magic. We can see the before and the after. So no more at least huge piles of debris or anything like that. The big sander's cleaned off. I don't usually clean the drill presses as they're just going to get chip on them again anyways. And I will clean them once they get extraordinarily dirty, which is not right now. Now that the SC's new catch can is built, it's now time to mount it. And this is the point that can be a little bit tricky and a little bit cumbersome, but never fear, I'll go over this and show you guys how I do it, and hopefully you can apply these techniques to your projects and it'll make your life a little bit easier. So you guys have heard me talk about 3 points of contact, and what I mean by that is whenever I'm mounting a can or any sort of component like this, I like to mount in 3 locations to avoid having it be able to move and vibrate around. If you mount in just 2 spots, well, then you have kind of the ability, if we use my hand for an example, where if my pinky and my thumb are 2 mounting spots, well, all that you do is create a pivot point. If I put my index finger out and it's tied in, well, then I can't really move one way or another. And that triangulation of your mounting points will really help to make a can or a tank or anything along those lines very, very solid. I also advise against using lines or hoses or tubes or things along those lines as your 3rd point of contact, as a line it would be more easy to bend, and oftentimes a line that would be running to a catch can or something along these lines, we'll even use a fuel tank or fuel rails for example. You really don't want to run the risk of rupturing a fuel line in an engine bay with a bunch of hot stuff and things that could be potential fire hazards. So it is not as big of a concern with a catch can, but it's still something to keep in mind. So also, if you guys look kind of down in here, you'll see that I have a piece of 1/8 inch aluminum, using it as a spacer to keep the can off of the chassis, and again to avoid having any vibrations or the possibility of the chassis abrading through the catch can as time goes on. So with all of that being said, now we need to figure out where our mounting locations are going to be. So I think the most logical spots, I have one threaded hole on the chassis right in front of my index finger there. I have a stud right here, and there's another threaded hole on the side of the chassis over here on the upper frame rail. Now, there's also the option to put riv nuts or some sort of a threaded insert into the chassis, but rather than drilling holes in cars that now are not easy to be replaced, I'm an advocate of using factory holes and factory locations, if you will. As then you're not modifying the chassis, it's just a simple remove a bolt if you don't want that component in the car any longer, as opposed to if you drill a hole in the car, well, you can't really undo that very easily. So with all of that being said, let's go ahead and figure out what tab I'm going to start with. I'll probably do this one over here, as it will be the most difficult of the three, most likely. I'll get that set. That will set my position of the catch can in the engine bay, and then I can build the other two to suit from there. This first tab is going to be pretty straightforward, not anything outstanding or outlandish, but when you still think about making even a simple tab, you have full autonomy and liberty over how you are going to design it, where the hole ends up, where the bend is going to be, so on and so forth. What I'll generally do, and I have kind of a standardized process that I use for this tab is going to be bent 90 degrees, and it will have a hole for an M6 fastener. For an M6 fastener, I'll generally drill a 1/4 inch hole. It has just enough tolerance where you don't need to be 100% precise with where the tab's located. You have a little bit of slop, and I don't say slop in a negative context, but you don't have to be 100% exact, as pretty much nothing that we are doing as welder fabricators is truly 100% exact. So with that in mind, what I'll usually do is space the tab down 1/2 inch. And with this being a 1 inch wide piece of strip, our center point will be 1/2 inch as well. And with those two little hash marks right there, I have the center point, or I have the point where I'm going to drill my hole. Now, with my hole drilled and chamfered and all of that, I can go ahead and put my bend in this tab. Now I'm using, this is just an Amazon rod and strip bender. It's just 3 pegs that stick out. You put your piece of material in, and it will bend around this tab, or this post right here. So I have a mark on this already that I'm going to line up pretty much with the center line of the bending peg. And all that I'm going to do is take and gently bend this around. So I'm aiming for a 90-degree bend. And that right there should be pretty close. The nice thing with bending around a radius like this is you aren't cutting into the material at all. It's a nice smooth bend, smooth contour, as opposed to if I were to clamp this on the side of the table and hammer it over, well, I'd be much more likely to end up fracturing this or putting undue stress on this aluminum. This is a much smoother and nicer way to do it, and at this point, we're ready to measure and cut this tab off. Well, I have the first tab tacked on, and I tacked it on just this side right here, if you guys can see that. So that way, if I need to rock and move this thing around at all, then I can. So at this point, the goal is to get all of my angles set where they need to be, and all of my positions and everything else. As you're doing this, always be sure to actually tighten your fasteners down. Otherwise, you may not be in the position that you truly want to be in. I'm pretty happy with that right there. And the last thing is to make sure that my spacing off of the upper frame rail, or at least how it appears aesthetically in the engine bay, is correct. I think I'm happy with that right there. So now, very carefully, I'll pull the can back out of the car and go over and fully weld this tab, so that way its position is locked in place. I'm not fighting it with the other tabs. The first tab is all squared away, and I'm re-leveled and everything else. You can see the tab there. And I did discover right there is another M6 threaded hole in the chassis. So rather than using the stud, I'm going to use that M6 threaded hole, as I'd rather have the 3 mounts be bolted in rather than have to contend with a stud that might make it a little bit more difficult to get the catch can in and out of the car. But if we look at it from the front, the catch can looks nice and aesthetically correct. It's level and all of that. So I'm good to go with the second tab. So it'll be very similar to the first one. Mark out, drill, bend, so on and so forth. So I'll spare you guys that. It'll be a repeat of the same process, and I'll go ahead and knock that out right now. And just like that, the SC now has a new catch can. So I went ahead off camera and I modified the 2 breather lines. I got everything squared away. The catch can is in here. The drain plug is in the bottom of it. And I even went ahead and I made a little dipstick. So in keeping with the theme of doing this as cheaply as I could, the dipstick is made out of a bolt that I had around, a sealing washer, and then a piece of stainless filler rod. And it will do its job perfectly fine. So now that this is completed, you can see I have the turbo torn apart, building an extended oil return flange fitting, adapter, whatever you want to call it. Building one of those to get the oil return line in a bit more advantageous location, but that is something I'll knock out off camera, as I think you guys have listened to me drone on for long enough. So with that being said, that'll be the end of this one, so let's go ahead and wrap it up. So thank you guys as always for coming along on all these different adventures and journeys with me. Hope that you guys learned something in this episode, maybe some new things to apply to catch cans that you're building, maybe how a catch can works, what their general construction consists of, what have you. I'm happy to have been able to make this episode for you guys, and hopefully you guys learned something, and hopefully you can apply it to your projects. But we are making really good headway on the SC Resurrection. We have the whole hot side wrapped up at this point in time. And the next thing to do will be the cold side, so the intercooler tubes. The hot side intercooler tube, cold side intercooler tube, locating the blow-off valve, so on and so forth. We will get to that in an upcoming episode. But with all of that being said, that'll be about the end of this one. So as always, be sure to subscribe, leave a like, leave a comment, check out the website for manifolds, for merch, for all things good that way, including my 15th anniversary t-shirts and hoodies, available through the end of 2024. So scoop those up while you still have the chance, because come 2025, they will be no more. But with all of that being said, that'll be the end of this one, and I will see you guys in the next episode.